Welcome back, and welcome back to part 4, where I've started now working on replacing the capacitors. From my last video, I cleaned it up. I took a bunch of junk off of this. I polished it a little bit, so I got it to this point. So as you can see, I've started replacing some of these capacitors and some of these resistors. Now, I want to talk to you about some of these components. And I know a lot of folks out there who are following me from home and also working on their vintage boat anchor, shortwave receiver or whatnot. If you come across these capacitors, and a lot of them do, a lot of these vintage tube receivers do have those older capacitors. You know, these are very, very leaky, and they will start leaking, and all of these leak. And I've tested it with my capacitor leak tester. And all of these are resistors now. They're not capacitors anymore, they're resistors. And if you recall from the last video or from my first video, I had another parts radio, and that parts radio had a replaced transformer. It melted, and I'm beginning to wonder if the previous user was using it and never replaced these components, and these components slowly started leaking and slowly started becoming resistors. And as they started becoming resistors, obviously they're going to load that transformer, and that transformer probably got super hot and melted. And I'll put a little quick link on my description so you can see the transformer in question. But yeah, I gotta believe that my donor part, or my donor receiver, it has a bad transformer, or it has a replaced transformer, and it's gunk all over the place, if you recall. And sure enough, it's the culprit is these capacitors. Now let me talk to you about what I found and some of the gold nuggets in here. And it's interesting to see, and I have to believe like the previous person who was using this receiver must have pulled out their hairs trying to figure out what the hell was going on with some of these intermittent function of this receiver. Now, as I started going through replacing capacitors and expecting cold solder joints and expecting all these components, a lot of things started popping up as far as possible issues that the other user was coming across. And just let me show you on some of these as I start replacing these capacitors here. So I started replacing all these capacitors and some of these resistors I started replacing now. And take a look at all these capacitors. I will start replacing all the resistors every time I work on a new receiver. I replace all the capacitors on all the resistors. Some of these resistors will be within tolerance, but they're all carbon composite. And I don't know about you, but some of these carbon composite, after some time, they create noise. And I don't want noise on my receiver. I just want the static and the station to come in. And some of these resistors do become noisy, and some of these capacitors, so some of these micromold as well, they do become noisy as well. So I'm gonna go ahead and start replacing everything in here, but I want to show you something that I found. Now this socket belongs to this 6J5, which is the beat frequency oscillator, or the CW. And come take a look, get closer. So this is the connection. To see this tubular thing? I guess Hallicrafters back in the day, that's their way of insulating. Instead of using a shielded cable, they've used this. And this goes to the CW capacitor back in there. Now take a look. After a while, some of these components, let me remove this resistor so you can see better. So let me zoom in. So see this wire right here? It goes inside this tubular thing, this insulator, and it goes into this little connector right here. Now, if I tug on this connector,
me zoom in. See, there's no connection. After a while, this wire becomes builds up some sort of carbon or some sort of thin layer of corrosion, and that won't make any contact on this socket here. So I'm assuming the person who had this, if they lived in cold weather, this inside, let me zoom in, this inside there would have not make any contact until either the temperature got really warm outside or until the receiver got really hot in here, and then it started making contact. But you can see on there, cold solder joint. See? No connection. Ain't that something? So as you start going along and you start looking, doing your recapping of your receiver, pay attention to the cold solder joints. Just because it looks like it's soldered on there doesn't necessarily mean it's making a good contact. Now look, I'm kind of curious about this connection right here. Where is it? Where is it again? I lost it. This one right here. More my focus camera. Focus. See how close. See how close this metal part right here is to this. I mean, yeah, it's not making any contact. But I don't like that, so I'm going to peel this back just a tad bit and clean this up. So yeah, it's a lot of work. You gotta pay attention. You gotta pay attention to these old cold solder joints because they'll drive you crazy once you recap everything, replace all the components, and you swear you have the right resistor and capacitor, and all of a sudden it's acting funky, and you can't get it to work the way you want it to work or the way it's supposed to work. And a lot of times it's cold solder joints, and cold solder joints are real, and they can give you massive heartburn and trying to figure this thing out. So this is where I am. You can tell some of these capacitors have been messed with, and yeah, it's coming along little by little. Look at this right here. Can you focus? Hello. See this this resistor right there? I'm not sure. Oops, I hope I don't get you dizzy. Oh, there's a capacitor down there. See that one right there? Interesting. And now I want to show you something else. See this twisted pair right here? Let me move this around so you can see better in the light. Give me a second. I want to show you something that I found on some of these radios. Where is it? Right there. See that right there? Where it's not making any contact? This is actually a capacitor or some sort of capacitance. So they're trying to achieve a capacitance by twisting these two wires together. And I looked at the schematic, and that's a 3 picofarad connection. So, yeah, it works, but I'm going to go ahead and try to replace that with an actual 3 picofarad capacitors that are having these exposed wires, because if you do touch those things, you're going to get a not so pleasant zap inside your machine, or something might just not go the right way. So look at this. There's a lot of corrosion. A lot of folks were telling me, yeah, I wouldn't have done that. What you did, you put too much of that cleaner in there. But you know what? No big deal. Nothing. I'm replacing every component. And these wax on these coils, nothing happened. If anything, it did a big favor cleaning up the connection. You see the inside there, the rotary connection? I mean, after using some of that cleaner, it took a lot of the carbon composite or that carbon stuff off of those wafers. Yeah, I could have done it a different way, but this was my part machine, or my parts radio, so he didn't care for it. So I just went ahead and gone with it and see if anything, if I can clean it up. Let me zoom in so you can see. So yeah, so try to pay attention to some of these cold solder joints. I'm going to go ahead and replace everything in and replace these resistors, kind of fix that up, and this capacitor here, fix that up. Some of these older capacitors have a little thin film of silver, and that thin film of silver it oxidizes, just like these right here. See how this is starting to oxidize? I mean, it's still functional, but I don't know, it doesn't look. Let me tuck that back in there. So yeah, that's where I'm at. I'm replacing. I don't know why this camera does this funky, doesn't automatically focus. So yeah, these are where I'm at now. Replacing all the capacitors. And some of these capacitors that I replaced, looks like somebody before me was in here and monkeying around and replacing some of these with a different value. And it's interesting how the values of the components in the schematic are a little bit different than what's comes out of the factory. Like for example, some of these resistors are 3K resistors right here, down here. This green one and this green one. In the schematic, it calls for a 3K replacement, but when I took it off, the previous one, it's a 2.7K. So this one right here. So I'm not sure if it's something that the factory later on went and replaced this, or it's just within 20% tolerance, or that's what they had in stock. But if I measure it in my focus multimeter, it goes and measures over 3.5K. So yeah. So now let me show you real quick, just so you can get an idea of what I'm talking about. I'm trying to do this with one hand. So let me take one of these capacitors, and I want to measure this is a, come on, zoom in. This is a 0.2 microfarad. And what I'm going to do, and I clean that up. I'm going to connect that there. And I'm going to connect this here. Okay, now, so it's rated at 600 volts, right? Yeah, I don't want to blow it up. So it's rated at 600 volts. Get this out of the way. Let me show you what I'm looking at. So I'll leave this here so you can see. So, turn the power on. And I'm going to crank it. I'm at 10 milliamps. I'm going to crank it. Oh, it's going to make a liar out of me. Well, this one's good. I mean, not good. I mean, this one's, I'm at 250. And, well, this one, hot dog, this one is a good one. Well, I'm at 100 microamps. So there's leakage there. I'm only at 250, so if I crank it out to 300. So this one's not too bad. Turn it off. Let me grab another one. So let me grab, here's what is this? 0.5. Let's do a 0.5. Okay. Sometimes I wish I had like 3 hands. Okay. So now you got 600 volt 0.5. Let's bring this up. 300. Well, what happened? You still got 100 microamps. Let me see some of these. You can see there's still a leakage there. How about this big old, this 0.1? How about this? Just try this 0.1 at 600. Turn off the power, let it drain, and bring the power down. So I mean, yeah, 20 microamps, 40 microamps. It adds up because you're connecting all of these. So let's try this one again. So let's bring it up. Do 300. Whoa. So prime example. Just look at this one right here. 20 microamps or milliamps. 19 milliamps if I crank it. Almost 20 milliamps on just one capacitor. Not good. Let me test some more. Bring the voltage down. Let's try this. What is this one right here? Let's try this. Zoom in. Put this on the ground. Come on. Another 0.5 at. This is 200. So I gotta watch out how much voltage I put on there. So let's put this one right here. And connect this right here. Get in there. Okay, so you got that. Don't move. You got that right there. So let's crank this on, turn this on. Ooh, not bad. This one's a good one. Oh, not bad. Okay. So see, I don't know why, but yesterday when I was taking these apart, these dang capacitors were testing really high and really a lot of current drain. This is at 400.1. Let's see. Crank it up. Oh, look at this one. 10 milliamps. I'm at 200, but it's coming down. Let me crank up because it's rated at 400. Let me do. Ooh, it's beginning to short. 100 milliamps. Ooh. This thing is gonna blow up. Almost 300 volts, and I'm at 100 milliamps. So 200 milliamps. Am I reading that right? Dude, this is gonna blow up. Yeah, so there you go. There's a lot of capacitors in here that are beginning to drain and start acting like resistors. So my recommendation, replace the capacitors. Don't be cheap. Just go ahead and buy some of these capacitors and replace them. Yeah, it's a hassle. It's a pain in the rump to go in there and start replacing. Like, let me show you real quick down there in there. I'm not sure if you can see. Way inside there was 3 capacitors and 2 resistors that I had to somehow dig out. See the capacitor right there and the resistor right there. Yeah, it's a pain, but you gotta do it. Otherwise, you will mess up your transformer. You will short it out. You will blow it up. And oh, let me flip this over real quick so you can see what's on the other side. I'm gonna put you on hold, okay? Okay, so this is what I've done. Oh yes, I wanted to talk to you real quick. So for my last video, I'm not sure if you were paying attention or not, but in my last video, let me flip the right. Hold on. Okay, my previous video, let me zoom in there. These, you see this right here? That clamp right there? Let me zoom in. Let me try this. Camera's acting kind of funky today. What's going on here? Focus. Oh, it doesn't want to focus now. Come on, get in there. Well, anyways, just hope you can see. You see this little clamp right here? Now this little clamp holds this tuning condenser and this tuning condenser. So every time you move the tuning coil or the tuning knob, one moves and the other one moves. Okay, let me flip this around. Give me a second. Maybe it's the lighting. Okay, so this is a better angle, huh? Okay, there. So now you see that capacitor, that clamp, it was cracked. This was cracked in half. So every time I would tune or move this condenser, it would slip and this wouldn't turn. So what I did, I cleaned this using some alcohol, cleaned it, and I had some solder, some flux, and I used one of my hot soldering irons. I think it was an 85 watt. Put some solder across that, and look, beautiful. Now it's nice and tight and clamped. So I'm not sure this is something that a lot of Hallicrafters suffer from, but this one definitely had a crack. Say no to crack. It had a little crack down the shaft. You said shaft. Anyways, so that's that. And this one right here, now it's working. So yeah, so like I said, this is the clamps are very cheap. This is some sort of tin, and I've used solder because there was a crack across this shaft right here. So no matter how much you spin, this just wouldn't clamp on. So this is what I've done. So if you have your Hallicrafters, pay attention to this. If it starts to slip, or if the frequency doesn't match what you're hearing, pay attention to see if this is slipping. And if it is, you might have to go ahead and clean this up and solder it, just like I did, using one of those big old soldering irons. I used an 85 watt vintage soldering iron, and I did the charm. Make sure you use a lot of flux. And like I said, that they cleaned it up. So anyways, this is where I'm at. I will be taking apart these cans. I'm gonna go in there. I'm gonna show you what I find once I start going through the whole resistor and capacitor. So my next video, I'm going to put a video together on where I'm at with all the capacitors and resistors. Now, I'm debating. I'm going to leave this capacitor here, but I'm going to disconnect it, and I'm just going to go put the new capacitors underneath it. I'm not going to try to restuff this. A lot of folks, they like to restuff these old capacitors. I'm not doing that. I just don't like that. But I'm going to just disconnect this, remove all grind down the pins so nobody can accidentally reconnect it, and just put the little capacitors next to it. Besides, you're looking at 10, 20, and these are tiny. Look at the replacement. I got a 22 350. I got a 10 450. And 47. I got another 10. Well, it depends on your. This is a Nichicon. These are the nicer ones. So yeah, I'm gonna do that. I'm gonna go ahead and work on that too. And yeah, this is where I'm at. Your first thing you want to do is just replace all the capacitors, take them all out. If you're using this receiver or you're using a receiver and you said, oh, I tested the capacitor, there's no leakage test, oh, it's not leaking, it's not, you know what, it will leak. It's just a matter of time. Just go ahead and replace it. Go ahead and swap it out and do yourself a favor, swap it out. Another thing real quick, these older, and I think I mentioned it early in the video, these older resistors right here, these are noisy. I have a device here somewhere. Where's my device? I have a device here somewhere where I can test the noise of these resistors. I put 160 to 200 volts, sometimes 300 volts, and I can hear the crackling across that resistor. And I like I told you, I don't want that, because you all you hear is crackling in the receiver. So I'm gonna use these right here, these replacements. So I'm gonna use that. So anyways, enough chatting, enough talking. So thank you for watching. Thank you for putting up with my videos. If you're new a new watcher, please subscribe. Give me some comments. Give me some feedback. What do you think? What works for you? What are you doing? What works for your? What have you discovered? I'm not sure. I mean, I'm used to the. Like I said, I'm used to replacing all the components. All the resistors. I got a little bit of time. I'm only doing this on the weekend, so yeah. Thank you for watching. Thank you for your input. Please stay tuned, and I'll make more videos. I know a lot of folks out there will want to watch. I know, like for an example, for myself, when I get a new radio, I go online and try to see if anybody else has any experience with this, or monkeyed around with it, or farted around with it, and see what they come across, and if it's worth me purchasing or buying or not. And I think these videos do make a big difference for folks out there who do want to get into vintage audio or vintage receivers. You know, you can make the decision on your own if you want to buy it or not, or invest the time, because it is time consuming, and you are going to get a lot of heartaches trying to figure this thing out. Well, anyways, enough chatting. Talk to you later. Thank you so much. Until the next video. Take care. Bye.